as market participants. But when we start talking about distribution system market, that is a role of the customers to participate in markets and create the value from those markets. So we've got to put that together to make that attractive to customers to want to participate. We've also know that there's a retailer that provides energy services, typically supply-side energy, and in the UK there's a separate retailer. In other jurisdictions there's a separate retailer that supplies energy. But when we start talking about a distribution system market, it's much more than energy, and we've heard that on the other panels. And that's why we need to have a role of an aggregator. Now, the aggregator could actually be the utility. It could be another provider who provides aggregation services. But the whole idea is that we can package together what available resources could be in a neighborhood, could be in an individual facility, and creating a market around some smart apps that customers would want to participate in and would aggregate their own energy, distributed energy services, but it could also aggregate larger neighborhood or region distributed energy and create a bigger market for those as an aggregator function. And typically would expect those to provide some smartphone apps, those types of things that could bring these things together. Sorry about that. Don't know what happened there. Okay. Okay, and then finally there's this new role of a distribution market operator. And again, this could be the distribution utility, and there's some benefits of having a distribution utility to that. It could be a separate entity. But the whole idea of a distribution market operator is to provide the clearinghouse for identifying the distribution system needs from a capacity or a service standpoint, and connecting them with the market participants who have the available capacity or have the available resources to meet that need in a more cost-effective method than others. So when we start talking about that, the utilities need to have a very clear view of what's happening on the customer. I know we've talked about beyond the meter, but if utilities continue to have the role of providing safe and reliable service, they actually need to know what they're serving. They have to have some view of what is in that customer's presence and what energy resources could be available to respond to market needs. And so that means we have to have a new view, a new model of distribution operations that actually goes out and includes the customer and the distributed energy resources the customer may have that would participate in the market. So modern home, this type of home could be built today, includes rooftop solar tiles, electric vehicle charging, smart inverter, storage, battery, demand response, very efficient, insulation values, and that itself can create market value to the utility with things like aggregating things like demand response capability, where there's enough thermal insulation in the house where you could turn off or turn down that air conditioner for a period of time, and you have enough thermal insulation that it wouldn't be too big of an impact or too disruptive for the customer, as well as electric energy storage, of course. And then there's some other things at play that could be very valuable to the grid in the terms of responsive to voltage response and frequency response. And that can create a market for things like synthetic inertia, where it can create a more stable grid by having appliances automatically respond to disturbances on the grid. So let me continue that thought here a little bit. So we talked about the need to engage customers in an energy market. How do we do that? And part of it is applications that are cool that they want to engage with, and in giving them some way to incentivize them to want to participate. That does not take a lot of configuration, a lot of setup. Yes, there will be a few tech heads that want to get into that kind of stuff, but not the average utility customer. And there will be a need to have tools for making this easy for the customers to participate. So things like behavioral demand response, that's certainly available today. Appliance marketplace, where you can identify where's the lowest cost place to get the most efficient appliances that have IoT capabilities that can respond to the markets, that have the capability to respond to markets, and then also targeted programs where utilities can identify where these grid constraints are and proactively market these incentives for utilities in these specific region or neighborhoods to participate in these types of programs based on utility need. So I just want to have just a real fundamental conversation about the market process. And I came over from the airport this morning in a lift, so it's a good way to talk about the market, and then we'll talk about how does this relate to the utility market. So I needed a ride, picked up my smartphone and used the cool smartphone app, and it does location-based services of who is available to give me a ride based on the needs of where the needs are, and it's a location-based optimization based on traffic patterns and availability of drivers, qualified drivers, and gives me options to say, yes, there's three nearby here. It's going to cost you about $30, 20 minutes, and then I say, yes, accept a driver. It assigns me a driver. I have the option to opt out. If I don't like his ratings or qualifications, I can opt out and pick a different one, and they'll arrive in 3 minutes. Okay, then I get picked up on my way. Something happens and says, there's an accident ahead. Is it okay if we take an alternate path? And it's like, yeah, that sounds great. And then there's a settlement. Good ride. I'm going to give him a tip. Charge to my account. Settlement. The transaction is complete. Okay, so let's apply this same methodology to distribution operations. Okay, we evaluate there's a need. There's a need for a distribution need. And in this case, large penetration of rooftop solar in this neighborhood is predicted to cause intermittency. So cloud comes over, the output of the solar drops, the voltage drops, and now we've got a violation of our voltage standards because we are predicting the clouds based on weather predictions. The output of the solar is going to be dropping at a significant rate. And by the way, we had to prop up the voltage earlier in order to support the low voltage problems we had before, but now it's going to drop below that. So now we need to do something about that. And so now the utility can go and request a need to say we have forecasted a need. And by the way, this could be a planning process as well as an operational process. So certainly it has to start with a planning process to identify where the needs are going to be. So that means we need good forecasting tools and things like forecasting adoption rates of rooftop solar, adoption rates of electric vehicles, and things like that that can cause this kind of disruption. And then we can target location-based targeting of where we can go and identify which customers are going to have the best impact on mitigating this need. And then the market application, the cool market application can say, yep, there's available DER resources that have both real and reactive power control capability. And there's 3 inverters available, and these customers are willing to participate. And then for some preferred DER incentive rate. And then you can go ahead and request that DER, and then now these 3 smart inverters are now at the control of the utility for controlling voltage to mitigate that expected voltage deviation. There may be event control happening to say, the participation rate did not give us what we expected, not what those customers signed up for, or there may be extenuating weather conditions, and we need to go request more. And so that would be the event control that we'll have to go get some more resources. And then there's at the end of the event, we would reward good performance and penalize poor performance based on the agreed upon terms of the participants. So it's very similar as requesting a ride share. Obviously, there's a lot more complexity behind that, and it's all about the platform, the distribution platform. And again, I need to share just a real quick example. We've heard this before, that iPhone is an example of a platform. It's a tested technology that has scalability, performance, resilience, security built into it, and it has underlying operating system across the core that provides services out of the box that make those services available to all of the apps, all of these apps that are available that can leverage these services to provide optimization for the user. And also these apps are updated frequently for security reasons or added functionality. Those are all good things. Let's apply that same thought process to a distribution grid platform. Okay, so we have a distribution grid platform that starts with a network model. A network model is how everything is connected together through the lines and wires from the transmission substations all the way down and including the customer. We need to have tools that keep that model current, such as GIS. We bring in SCADA, AMI, other sensors, other points of reference that can give us insight into this model that we can create a real-time operated model, and we can actually use that for forecasting the future. And then we can do power flow state estimation techniques off this model. That also includes the customer distributed energy resources. So it is a complex model, but there are tools to keep this available, keep this current. And by the way, this model, the core to that model has been used for outage management system for years. And utilities have continued to evolve this model to support things like switching for automated fault isolation and restoration, volt-var optimization, even comms management, device management. I mentioned tying in forecasts for doing longer-term operational planning. What's going to happen over the next 7 days based on weather conditions? There's no reason why you can't have a model that what we call future state models, where you can look at it from what will the model look like 5 years from now based on the forecasts of load, the adoption rate of EVs, PVs, all those things. And then use that for creating your energy markets, because that's the same model, it's the same platform that is required to understand what is needed from a planning perspective, and then what are the alternatives to a traditional wires or new substation or new line extension. Are there cost-effective alternatives that can be offered into the market to mitigate large capital expenditures, or defer them to a point when you do need them, that you have a utilization rate that justifies that expense, and then also becomes a platform for things like transactive energy. Okay, so let's talk a little bit more about the grid management and the market operations. How does that interplay with each other? So we have the grid management platform. Again, that's the model, the real-time model optimization engine that includes the customer's distributed energy resources. That model can, like I just said, can be used for planning, can be used for operational support, including major storm events and things like that. For microgrid support, operational control and forecasting the need for additional reactive power for voltage support, even things like frequency response for synthetic inertia for stability and things like that. And then the market operations, and then the distribution market operations would be the new application that would be based on locational marginal price. We've been hearing that throughout the day, of the need for locational marginal price down to the distribution connection points. And that would provide markets for distributed energy resource participants. It would be a market that would be based on capacity, energy, as well as voltage, reactive power, and frequency and stability. So the distribution grid management solution would then, our grid management platform would identify what are the current needs on the grid, where are my constraints based on overloads, under voltage, over voltage, those types of things. And those can be planned out into the future, as well as from an operational perspective on a day-to-day basis. The longer term requires to go enroll customers to participate and be available to engage when the market is needed. Within that market response, there is a enrollment loop that goes back into the market to say these customers are now available, and the utility can engage them to participate in an event, and then would call upon them on the operational need for the event. Okay, so let's just give a real practical example of electric vehicle charging. So go get a new Tesla, drive it home, plug it in. it's all great, except you might have just overloaded your network in your neighborhood and causing disruption to all your neighbors. Certainly, the smart meters have the ability to do pattern recognition to identify what a electric vehicle charging load looks like. It's pretty understandable load curve, flat charge for a number of hours and then drops. Other load curves are very cyclical, and so that can immediately trigger the platform to go look to say, do we have available capacity to serve this electric vehicle? The first one might be great, but then the neighbor next to you decides he really thinks that's pretty cool and goes and buys one and plugs it in, and that's just overloaded the network. So the next one would be too much. So that would trigger the need to say, okay, in order to mitigate this, this is what is required from an infrastructure perspective. But we can look at alternatives to the infrastructure costs and say we can mitigate infrastructure costs by providing smart electric vehicle charging rates, because there's plenty of available capacity, but it's only in the nighttime hours. And so if we can go target market electric vehicle charging rates that are targeted towards when there is available capacity, that's a win-win, because it improves our utilization as well as keeps costs down for the customers. Okay, so market design considerations, and this is just to summarize my talk here, is that IT and OT and CT, system architecture, is needed for a market consideration. And it needs to be able to support growth from multiple participants across the grid and scale to every customer ultimately at some point. And each customer may have multiple devices that would need to participate, or that could participate, that could be aggregated up. And so the systems have to be able to support scalable performance as well as planned growth. They also need to be very agile, meaning the markets are going to be changing quickly as technology is changing quickly, and the needs for these systems have to be able to adapt to new market opportunities, new technologies, and keep up with the pace of change. Sorry. And then finally, in order to be valuable for the utility, these participants, or these DER market participants, need to be available, reliable, and responsive, meaning they need to be there when they're called upon, and they need to be responsive. In order to be an alternative to a utility asset, it has to have the same type of characteristics as a utility asset. And so that's the point, is the value to the utility of a DER has to take into considerations the safe, reliable, responsive nature of them. And then finally, the platform has to include the model and an optimization engine. It has to be scaled all the way to the customer to include all of the core technologies. Also be able to support locational marginal price throughout to support DER resources for energy, voltage, and frequency markets. And then finally, the market needs to, or the Commission would need to support incentives for the utility to invest in DER as a non-wires alternative where appropriate. And so that requires some rate-making structures that would provide those incentives to make it the more attractive option if it's lower cost than putting in traditional wires and lines. So thank you.
Thank you, Bradley. And who's up next? Is it Sandy? I think you are up next. Go ahead, please.
I don't want to be the last one on the last day.
I'm just trying to get out ahead of Dr. Paul Zinger that I know he's got coming.
He's gonna. He already did that in practice. So.
We anticipate we're saving the best for last.
Oh, okay. All right. Well, thank you for the opportunity to be here and share some thoughts with you today. I am from the Bridge Energy Group. We are a consulting and system integration company that is 100% focused on the utility industry, the energy utility industry in particular. So we are focused on grid modernization, operations, optimizing the grid, using analytics to support the decisions that are made on the grid, and then of course the ever importance and not to ever be overlooked security and making sure that we're enabling security as we're adding all this new stuff, as we'll call it, to the grid. So we support the entire energy life cycle with our utility clients, from strategy and planning through the operations and system integration and implementation of the different things that they're trying to do, and we'll also help them operate those systems. So just wanted to level set. We are 100% focused on the utility industry, so we're big fans of the utilities. So just a quick overview. I think we've talked about this sort of a lot today, and throughout this whole process, I think you've talked about this as well, is really that grid modernization, it's not a thing, it's not a piece of equipment, it is a process. It's a journey that we're all taking actually together, right, to transform our energy infrastructure, right? We know it's going to be more distributed, we know it's going to be more integrated in the future, and it is now more so than it was in the past. And so what are those things we need to do to make sure that we enable that? We've heard a lot today about how the grid is the platform, right? And really this is sort of our picture of what that means, right? And it includes, when we talk about grid modernization, we're talking about all of these things that I'm showing on this slide. We're talking about grid automation, which are the pieces of equipment and the systems and all those things you need to do, the meter, the enabling technologies that allow all these things in this dynamic grid to happen. And we believe that supports this far more penetrated and dynamic distributed energy platform that we have, right? Whether you're talking about renewables or non-renewable sources, whether it's large scale or in the home, we talk about microgrids and storage and EVs and all these different moving pieces and parts that we now are excited about, right? I mean, I think it's kind of cool, but we have to make sure that we are prepared and establish that. We've heard it a lot today, the platform to enable all of that, right? And once we start to do that, we are enabling that business model and market reform, and we're preparing ourselves for that, whether it's, transactive energy or service offerings that the utility can offer, or preparing to enable and ready themselves for offerings from other parties that are interacting with our customers and enabling them to interact differently with the grid. It prepares us for that. And none of that should be done without this foundation of understanding the data. How can we use the data? Who can use the data? Can we take utility data and offer that to others to manage their grid? And we have examples of where, there's not too many, but there are examples of where that has been very beneficial to the customers to be able to see not just metering data, but other types of information as well. So, how do you use that for situational awareness and visualization, not just at the utility, for others? So I think I just wanted to kind of level set. This is our view. I think it's pretty well shared. I've heard it a lot today as the utility as that platform. And that's really when I look at where our utility business is evolving to, and I've had the privilege of being involved in it from many different aspects, as a utility, as a provider, as a we're not supposed to say third party, as a supplier to customers, right? To watch this evolve, at the end of the day, I really think technologies and integration are the foundation to that marketplace of the future. Utilities are already implementing a lot of the systems and a lot of the technologies and the communications infrastructures that are necessary to manage those distributed resources. They already operate very complex networks and markets, and so to me, they are a very natural player in this space, right? They already have the inherent operational synergies to support a marketplace like we're talking about. I think they have the opportunity to be an operator of that dynamic energy marketplace, and we've heard differing opinions on that today, right? But But I think they are in an excellent position to do that. There's no reason why they can't. And I know we need to figure out where that line gets drawn, right? But you start talking about, I haven't heard the word smart cities in here today, but I know Columbus has a lot of activity going on in that space, right? What's the utility's role in that? You know, do they operate some of those services? I don't know. I don't know what that looks like, but they should definitely be a stakeholder engaged in that, because that energy marketplace and the infrastructure is really foundational to smart cities being able to operate efficiently and effectively. Can offer data management services. I've talked about that. And then we've talked about this energy exchange, right? At some point, they are the wires company that manages the flow of that energy, so I think they have to be at least a party to that discussion. And then how do you enable competition? Heard a lot about that today as well, right? And the utility is going to continue to own and manage that existing infrastructure, right? I think third parties should be allowed to offer additional distributed resources and technology opportunities to customers. It's part of living, I think, in America, right, is to be able to offer those services to customers and get people to buy our stuff. That's just all part of the society that we live in. At the same time, I do think utilities should continue to be encouraged to offer programs like our DERs and our bring your own device programs and things like that, so that they're offering programs to their customers as well, in order to manage some of the things that they need to on the grid. You know, we need to offer DR programs, and whether that's battery or however we want to, what technology you want to use to do that, I don't think it's less important as the fact that the utilities still need to have that conversation with the customer just so they can adequately manage the grid. I also think it's important to make sure that we have standards for how people interact, right? Opening it up to competition is fabulous, and I think we do some of that today already, but you have to have standards and protocols with which to come and play in the marketplace, no matter what we do. Couple of system, distributed system market models, and I know there are people in the room that can talk in far more detail about than I ever could about these, but what I thought was interesting is when you start looking at just a couple of the examples, right? Regardless of what has gone on in California or New York or the other places, they have used the available utility infrastructure as the foundation, as that platform for what they're trying to do. I think that's very common all the way across the board. In some cases, they try to use the current market structure, and others, they're testing market structures and trying new things. And we've talked about New York Rev a little bit already here today, and a couple of different things that people are trying to do there. And in some cases, the utility is allowed to compete, right, as an energy service provider, or an energy resource provider. And in other cases, it depends on the market, they're not. Except in some very specific cases where they may be allowed to own a battery for reliability purposes, right? They're grappling with those things, but they're trying it. And so the real key here is that they're trying things, they're piloting things. What works, they kind of advance, right? And what doesn't, they have the lessons learned. And I really think what the approach to the market really needs to be just like that. And I think what you guys are in here is what I would call phase one on my map, is really that whole assessment. What's out there, what's available, what can we do, what should we be looking at? And then it's really about kind of at a high level, that roadmap, where we want to be and where we think we want to be as a state, if you will, and what we want to offer to our consumers. And then putting together sort of that investment strategy for what that looks like, right? And how you open that up, and developing the programs then that support that. And then you do that iterative approach, just like we're seeing in these other places, is, they didn't go and figure it all out, because I don't think we can, because too much is changing, right? So trying things, piloting things, not maybe being okay to maybe not get it right the first time and quickly pull that back and fix it or adjust it, I think is really, really what we need, is the structure that we need to set up as we move forward trying to determine what this marketplace looks like, because I think it's going to continue to evolve. And as we move more things and open up more things, I think you will see the innovation, which might change. That's why you can't put that roadmap out in the front and then never come back and look at it. That iterative process also has to be this constant refresh, if you will, of lessons learned and understanding what new technologies out there and new opportunities and what are other people doing in other markets that we might be able to adopt. So while we're taking that iterative approach, I kind of said we need to focus on managing some of the key risks, right? You don't want, we've talked about it all day. The utility still has to provide safe, reliable power. Ad nauseum, I feel like I think every one of us has said that today, right? So we still have to do that with that in mind, obviously. I mean, I think at the end of the day, that's one of our number one priorities, right? But then I think we have to be careful about we want to avoid that inadvertent endorsement of enabling technologies. So you don't want to leave the utility vulnerable to having these assets out there that are being used but aren't being compensated. And I think that's one of the fears of the utility, right? Is making sure that they're not maintaining this big grid, but they're not getting compensated for it, but it still has to be there just in case somebody wants to use it. So how do we manage through that, and what does that look like? I think we have to be really careful about creating regulatory constructs that might preclude realizing some of the benefits of the technology, like microgrids and stuff. Do you really want a microgrid on the system that can't be islanded because we accidentally maybe put a regulatory requirement in place that caused us not to be able to do that? So I just think we need to be careful as we're going through this and be thinking about some of those kinds of things that, could be have unintended consequences as we go through that. So as we go through and add more of these renewables on the grid, and we're putting on enabling technologies, and we're allowing people to have access, well, they already have access to the customers, but we're trying to integrate those into the utility system. We want to make sure that we have those technologies with protocols and standards to be able to integrate with that. And I think we need to allow the utilities to make the investments necessary to ensure that happens. That's it. Thanks.
Sandy, thank you very much. Dr. Paul.
Thank you, Mr. Chairman. Good afternoon, everybody. And yes, it is the unenviable position of being between you and happy hour cocktails. So with that in mind, I will try to expand to fill the space so that we can really enjoy those cocktails, if you will. But thank you again very much for the invitation to come here and talk to you all about the initiative that you've got going with Power Forward and sort of my knowledge. Now, I'm going to take a slightly different point of view from what you've heard today. I think probably closest to what you've heard so far today to where I'm going to be is what you heard from Paul Senalella talking about platform markets and really looking at the interface between distribution markets or the distribution system and the ISO RTO or bulk power system operation. Given that I've actually done a little bit of both even prior to my days at PJM, I worked on a lot of the distribution system operation, restoration, hurricane hardening down in Florida, work overseas with the World Bank on some of these issues, bulk power system, and now it's like I'm bringing the two of them together in much of this. But I think that I'm going to kind of step back from a lot of the talk of technology and information technology and operating technology and renewables and storage and all this other stuff, and just to say, as a true economist, assume all that. We know it's happening. We know the technology's there. We know that there are trends driving it, whether it's improved technology, reduced costs, as we've seen with solar and wind and storage, whether it's because people really value reliability, as we saw with Hurricane Sandy, or we saw with the hurricane seasons in 2004, 2005 in Florida, and we once again relearned the lesson with Hurricane Irma this last year. There's reliability value to having distributed resources. That kind of shows how much we're willing to pay, getting to some of the discussions that we had. That's there. But the question becomes, how do we integrate all this? Where are we going? with that. How do we want to look at this? And so I want to kind of bring this up one level a little bit before diving down into a different set of details than I think we've heard so far today. So let me just kind of get at the 10,000 foot level, and I'll do my best impression of Bill Hogan at Harvard and say, what's good market design? What are the objectives of good market design? And I think the first one is obviously prices should reflect the marginal cost of energy, whether it's by time, location, due to marginal losses, delivery constraints because of transmission congestion, or delivery constraints because of fuel constraints, such as we've seen in the PJM system historically with gas pipeline constraints, creating the transmission constraints. The second bullet, though, is one of these things I would really call, for those of you who are Trekkies into Star Trek, I call it the prime directive of wholesale power markets. That is, prices should be consistent with reliability and operational needs. While PJM and other ISOs and RTOs operate markets, if those prices are not consistent with the reliability needs of the system, with operational needs in the short term or the long term, markets don't matter because they're not accomplishing everything they need. Because you can't keep the system in balance, bad things start to happen. So really what we're talking about with any markets are these incentives through market signals. And I think we heard earlier today, the discussion of putting different resources, say storage in the right location on the distribution system to minimize losses or to defer or distribution investment. We're already seeing the same thing at the wholesale market level, where we're seeing generation locate in the most advantageous points. We're seeing new loads locate where there's less congestion, where prices are lower, given the signals that they're seeing, whether it's in the capacity market or the energy market. Those are the kinds of incentives that we're talking about that we want to have with good market design. There's another thing that's only been obliquely, though, referenced, and I'm going to address this directly here, is that the idea of pricing or cost allocation for the infrastructure assets themselves. In the wholesale market, you have transmission cost allocation, of which the biggest holy wars are fought over the smallest part of wholesale market costs. Sort of like being an academic, you have fights over the smallest things, not the things that are actually consequential. Not to say that transmission is not consequential, it is. Without it, we don't have markets, power markets. But the whole idea here is to get the prices right, get the cost causation principles right in terms of allocating those infrastructure costs so that they're actually consistent with what we're seeing with energy market signals in terms of location, time, and things of that nature. One of the other things, Paul Santalella brought this up, and I thought this was excellent, was the issue of transaction costs in different platform markets. And really, any good market is going to minimize transaction costs. Any market that requires a lot of steps to find a counterparty. And if we're talking about a power system, you can't take a lot of time, especially if there's a reliability issue. So, I don't mean to pick on you, Bradley, on this, but I found your Lyft example, which I am a Lyft user, by the way, quite informative, because if you're thinking about what's going on, I have a distribution problem, and you go through all those steps, by the time you get to step 2, it's too late. Bad things are going to happen. And so you've got to be able to have one centralized place, not just with markets, but also with operations, to make sure that all of this can happen simultaneously. And so, having a centralized marketplace where you don't have to go through lots of those steps, I think is going to be really, really essential. It's essential to good market design in general, but I think even more so with some of the things that we're seeing in terms of reliability. The last thing, though, is kind of interesting, is that to avoid uneconomic bypass in retail rate design. And this is one of the things that I've observed over time, and I've done some work recently in New York. Sandy, you brought up what's going on in New York with REV for the New York ISO, and it's interesting that with the value of distribution tariff, or the VEDR tariff, that's with the value stack and all that, and I'll talk about that in more detail. Now a lot of the players with behind-the-meter solar and distributed resources are saying, wait a minute, I like my net metering better than this VEDR tariff. This VEDR tariff is actually, so when you actually start getting out to the prices are right, you start realizing why people are installing these technologies. It's not always because of the economics or good economics. It's because there's uneconomic bypass. And I have another example that I'll get to in a moment. So my thesis here is that if we're thinking about market design at the distribution level, such as it is,
We've already got an example in the macro rather than in the miniature, so we're going to go in reverse. And that is, why not look to wholesale markets as a good example of market design? Everybody's talked about locational marginal pricing. I'm not going to beat a deceased equine animal over that again. Okay, I know it's almost 5 o'clock. I couldn't resist. Security-constrained economic dispatch and security-constrained unit commitment principles, the centralized energy market paradigm that I was mentioning. This is something that's actually, in spite of all the changes in all of the ISO RTO markets, especially in the eastern part of the United States, whether it's New England, New York, PJM, even MISO. The energy markets have undergone much fewer changes than capacity markets and transmission cost allocation and some of these other issues, or market power mitigation. These markets are fairly robust. We have effectively what boils down to standard market design in the energy markets these days. We have centralized platforms. Paul pointed this out in his comments. It works fairly well. Why do we want to reinvent that wheel when we don't have to? Plus, we've also learned a lot about transmission planning and system operation. We've learned what's good. We've also learned what's not so good. And we can apply a lot of those lessons here. But the other thing, I think, is to also take advantage of the economies of scope and scale, and that is, rather than inventing, if you will, whole distribution markets all over again, why can't we just dovetail everything into the wholesale market? Now, I know the question's going to come up, but wait a minute. Wholesale markets are federal jurisdiction. They're FERC jurisdictional. We're here at the Public Utilities Commission of Ohio. We're a state entity. We're not FERC jurisdictional. We have our own statutes and everything that we have to go by. All of that is true. All of that is relevant. But in terms of understanding the markets, why can't the markets still dovetail, even with that jurisdictional difference in statute? There can be ways to do this. As a colleague of ours at the California ISO used to say, there's no need for us to live in cylinders of excellence or silos. Let's break out of that. There's no need to necessarily here. And obviously with the uneconomic bypass, we know that there are, in some states where there is no retail competition, that we see large commercial industrial entities who would rather be in the wholesale market can't get there because of state law or whatever the case may be. So they're engaging in an economic bypass by building their own generation, because they can then get out of paying for tariffs that are just not very advantageous to them. Because again, the rate design is actually done very poorly in this case. So let me kind of start with a stylized view. I wanted to make this a little colorful. So think of this as a stylized version of sort of the bulk power transmission system and wholesale markets in combination with the distribution system. And you have multiple distribution companies surrounding the wholesale market, as denoted by the different colored dots and squares or rectangles. And each of the dots represents a node or a bus. So where you see the smaller circles, those are distribution buses connected to the wholesale or bulk power transmission bus. That's sort of the interface between the wholesale market and retail jurisdiction. It's also the interface between the bulk power transmission system and the distribution system. But they're all interconnected. If there's a major problem on one of those distribution systems, it will be felt on the wholesale system. Conversely, if there's a problem at the bulk power level, it's going to be felt at the distribution level. It is all part of the same machine in the Eastern Interconnect in which we're at. It's one machine. And so rather than treating it like separate entities, we should treat it as a single machine. We should treat that and think about extending a lot of the principles that are already being used down to the distribution level, or vice versa, from distribution up to the high voltage transmission level, rather than trying to separate these issues out. So the first thing we can think about with that is, and I'm not the first one to mention this today, I'm sure I won't be the last one to mention this in the Power Forward proceedings, is distribution LMP. There is no reason why, given locational marginal prices at the wholesale level, which have prices energy for congestion, losses, time, location, that can't be extended further down into the distribution system. Computationally, the distribution company or a distribution system operator can facilitate that, looking at that wholesale bus like a generator. Shouldn't be any problem. And then those price signals get down to distributed energy resources, and we find out truly where there are issues on the distribution system based on price. Because if prices are consistent with reliability, high prices mean there's some issues there. It brings some transparency, not just to the distribution operator, the distribution company, but it brings transparency to the customers to say, oh my God, if they could see these, this is a problem. How can we solve this problem and also help myself at the same time? Prices are sort of the control mechanism, if you will, to make these things happen. Or if we think about this from operations, and this is probably as important or more important than just prices from a market perspective. Let me kind of start from the perspective of looking at the distribution company as a distribution system operator, and I'll get into some of the ins and outs of who should be the DSO or not in a moment. But let's think about this from an operational perspective. The distribution system operator, the distribution company, knows that system. The guys in the control room at PJM and the planning department at PJM, for example, they don't know those systems. Not at all. Not a clue. They've already got enough to worry about. Just like the guys at the distribution level have enough to worry about with their own system, and they're not worried about the bulk power transmission system. There's just a little bit of bounded rationality here. I'm not suggesting we operate everything under one control center. But what I am suggesting is that a DSO type entity can look at its distribution system, understand where distributed energy resources are located on the system, roll that information up by interface with the wholesale bus, provide that information to the ISO RTO from an operational perspective and a market perspective. This is going to give the RTO a lot of visibility as to the resources available to it behind the wholesale meter on the distribution system that today it does not have any visibility over. Almost zero visibility unless it's going directly into the wholesale market, such as demand response or energy efficiency. There is no visibility otherwise. And in fact, the distribution system operator from an operational perspective sees that wholesale bus, that interface between transmission and distribution, from an operational perspective, that just looks like one big generator for that part of the distribution system. And then you can treat it with the DER accordingly. They can dispatch the system, they can operate the system as sort of a mini RTO, if you will. Why is that important? I think Ohio is probably keenly aware in the fall of 2013, when it got really hot after the summer. Actually, PJM, I think, peaked in September of that year, rather than in the normal summer months. There was a lot of transmission out of service at the time. There was load shed events for transmission-related issues in Michigan, Indiana, and Ohio. Different parts. I mean, it wasn't large amounts, but different parts of the transmission system. Yet, just couldn't handle it, and there was firm load shedding at the distribution level, post-contingency. As it turns out, when the analysis was done, there were actually behind-the-meter resources on the distribution system that could have been made available to prevent some of those load shedding events. From an operational perspective, that's a big deal. I can tell you, I certainly would have felt better about it, and I can tell you our operations guys when I was at PJM would have certainly felt better about that. Having that visibility is going to be really important, but even more to the point if we think about pricing, and this is not on the distribution level, I'm going to lay this at the feet of the wholesale markets, and forgive me, at the feet of my former colleagues at PJM. Part of the issue is that we're also not pricing everything down to account for some of these potential events. There are these events that there are these warnings called post-contingency load relief warnings that occasionally show up in operations. What that means, in layman's terms, is that if a contingency occurs because that part of the transmission system is kind of weak, load's going to have to be shed on the distribution level in order to make sure that the bulk power transmission system can be operated reliably. How often does that happen? Very rarely. Is that actually priced in? Almost never. If it were priced in, we might be able to see distributed energy resources available in those types of locations where these continue to pop up. And I can assure you, and this is a matter of public record, you could look this up on your own on the PJM website. There are certain circuits, there are certain locations that pop up over and over and over again. That could actually be very helpful from an operational perspective. So what does the RTO do in this case? Well, obviously, operating the bulk power transmission system, if they had that information, they could do a better job of dispatching the overall system, knowing what's behind the wholesale meter at the distribution level. And then those LMPs go down to the distribution level, provides the incentives, and you get this virtuous feedback loop, if you will, in operations and pricing. So, what time do I have here? Wow, I better get moving. It's almost 5 o'clock. All right, so what are some of the lessons here, though, from a more practical or governance point of view from the distribution system operator and RTOs? Well, I think one is the issue of independence. And one of the things that I've heard today, and I hear a lot, is that, well, the distribution company, the current distribution company can be the DSO. It can also play in the markets. It can do all this. There's a reason that the ISOs and RTOs are independent of market participants. There's a reason they are not the asset owner. Because it provides a set of incentives that probably aren't really good. So if we think about as a market participant, the distribution system operator being the distribution company and a market participant, you can imagine ways in which self-dealing can easily occur. You can also imagine from a planning perspective, if the distribution system operator is doing the planning and lo and behold, oh wow, we really need to plan for this given the current regulatory environment, it doesn't set up a good set of incentives. They may want to overbuild when it's not necessary, which means that the value of distributed resources and all of these new technologies that we're talking about goes poof into the night. It's a great way of foreclosing competition, isn't it? So we have to think about these incentives very keenly. And again, I think wholesale markets and the reason we have independence at the wholesale level is a good roadmap to look at. From an operations perspective, obviously distribution companies do a lot of the same things that ISOs and RTOs do. There's probably some lessons that can be learned on both ends here. As again, we saw with the load shed events, I think this really drives the point home that there's a lot that can be done. The last thing, though, is incentive regulation. And when I say incentive regulation, I don't mean rate of return regulation. I mean more regulation as it would be known in Europe or in Latin America as price cap regulation or revenue cap regulation, or as it's known in the UK as RIO. But effectively giving a stronger set of incentives for the distribution system operator, as is the case for National Grid in the UK, where they have their own set of incentives as the grid operator for the wholesale power markets. Same could be done for the distribution system operators. Even in PJM, their stated rate looks like a price cap type regulation, which is actually quite unusual given regulation here in the US in general. I've already mentioned planning. But again, the distribution system operator can also do planning. And having the visibility to DERs and looking at potential non-wires alternatives, if you will, having that option to bring on a storage device or contract with a large industrial customer for demand response to respond in the case of a contingency. These are not contracts that are unheard of in the industry. They do exist. Or sometimes they're non-economic contracts and they're often called special protection schemes. But we do have them. They do exist. Excuse me. So, having those types of things at the distribution level can help optimize the new distribution infrastructure versus DER, non-wires alternatives infrastructure, potentially. It also helps roll that up for the RTO when it's doing its long-term planning. So there's sort of an iterative process there that can take place with respect to that. But in terms of rate design and planning here, I want to bring up something, is that there are better ways to price the assets. And what I'm going to do is I'm going to hearken back to an old IEEE literature known as megawatt mile methods that goes back to the 1980s for charging customers. And when I say transmission customers, this could be load or generation. And I think realistically we have to look at both at the distribution level. But it's really a locational method for assessing wires charges. And I'm saying here it's akin to LMP. It's not exactly the same as LMP. But there's a locational component and a time component, usually dealing with the peak of the system on which the system is planned, and a locational component as to where the load is or the generation is and how it impacts the distribution system. What I'm suggesting here is that we do this for all assets, not just new assets, not just old assets, but based on the flow impacts on all assets. And yes, I am taking a veiled shot at transmission cost allocation in a certain RTO that happens to be located in a state to the east of Ohio with respect to this, in that DFACS, as it is known, has gotten a bad name. But megawatt mile methods, as they were originally thought, have almost nothing to do with DFACS as it exists today. And so, if you start hearing this terminology, I wouldn't throw the baby out with the bathwater. I would take a look more closely at this. And the examples I would use would be to take a look at what goes on in Europe and Latin America. And in particular, what I would look at, there's a great example from the UK. And this is on the bulk power system. They use megawatt mile type methods for allocating transmission costs. They allocate them across both generation and loads, unlike here in the United States. And what's interesting is because of the nature of the UK system, you can imagine lots of excess power in Scotland due to all the offshore wind. Where's the load center? London. That's the giant sucking sound where all the electricity goes in the country. If you're a generator in London, you actually get paid for providing transmission capacity because you're providing counterflow on the transmission system, in effect, because you're reducing the need to build additional transmission to bring energy from other parts of the country. On the other hand, wind generators in Scotland are getting dinged and they don't like it because they're far away from the load centers. But those are the right incentives. You want the generation close to the load. It's akin to locational marginal pricing in that sense. And you can extend this to the distribution level, and I apologize, but there's a shameless plug for some research that I've done with a colleague of mine from Uruguay more than a decade ago now when we started looking at this, combining locational marginal pricing for energy with a megawatt mile method that we coined the term amp mile method because we were just looking, rather than looking at real power, we were just looking at amp flows on the system because of the voltage variations on the distribution system. But it's akin to that, to the idea that you want to locate resources where they reduce their losses, and obviate the need for new distribution infrastructure. And I can certainly provide those papers to you all following the panel discussion and following the proceedings here. And finally, I've been told that I've run out of time. Like I said, I promised I would expand the use all the time and then some to make sure everybody was good and thirsty for those cocktails.
There are no cocktails.
No, I'm not saying that we're having cocktails on the work time. I'm just saying that after we're done with this, when you're on your way home, when you're going home, and
When I'm driving my kid home in his car seat in the back.
You've never heard of Pablo's drive-thru?
No, I don't know.
Never mind. That's an old story from my days in college in Gainesville. Anyway, now that we've really digressed here. The value of distributed energy resource tariffs, in New York, I think is sort of an example of this, what we're seeing at the distribution level, looking at valuing energy at LMP, or what they call in New York LBMP. They've, of course, got to be different. Paying for capacity based on the New York ISO capacity market prices, embedded environmental values, and also the savings for distribution infrastructure. But what's interesting, because again, these jurisdictional issues that keep coming up, is that there's the issue about Well, what if I have a resource that's participating in the NISO market directly and also potentially getting paid under the VEDR tariff? They can potentially get double compensation on some of these aspects here, whether it's energy or capacity. They could get some double compensation potentially, which then, again, gets back to the whole issue of an economic bypass. Well, I could get paid twice for doing this because the wholesale doesn't understand what the retail's doing, et cetera. Those are things that we have to watch out for, and that's why I mentioned to begin with, let's not work in silos. Let's kind of look at this as one holistic machine, even though we do know that there are jurisdictional issues. It means there's got to be some coordination between the wholesale and retail level. And so given that I've gone over time, I do appreciate your forbearance on that, and I appreciate, again, the invitation. I look forward to your questions. Thank you.
Thank you very much. Actually, we've done this in past proceedings, but sometimes we'll grab folks who have been on other panels and actually ask them to participate in the dialogue. So, Paul, I actually do have, if you don't mind coming up as well, because I just have a few questions about the platform concept, and I actually think I may ask questions of my colleagues and see if you can help us work through this, okay? So, Paul, I'm looking at your slide 3. And your slide 3 has the physical platform and the platform market, and it's broken up into these. Four different buckets. Okay. Now the physical assets. With respect to the physical platform, let's begin there. With the physical assets, I think we have had lengthy conversations about that. I think we can get to a place where we feel comfortable with the physical assets, and that we are allowing for investment in assets that will create a distribution system platform a physical platform going forward. System planning and operations, and so this is the discussion I think that we had 2 days ago about distribution system planning and some of the advancements that need to be made in typical distribution system planning. So I think that's something that we can also work through as well. It's when we start advancing into the platform market that I don't know if we can do, and I don't know what the steps are, actually. Okay. So let's talk about, forward and real-time distribution level markets, distribution location. So what you're really hoping for is as close to real-time pricing as we can get in order to create this transactional market that we're hoping for. Go ahead.
So that's ultimately where you want to settle at the end. So if you think about what the RTOs do today, they do a day-ahead market in the energy market, and they do a real-time market. The real-time market actually settles after the fact based on the actual flows and the actual demand and supply in the market. So in this model, you would take that real-time component down into the distribution level. You would look at what the actual power flows are on the distribution system. You would look at actual marginal losses, look at any constraints in the distribution system. You might include some impacts as you got impacts on equipment on the distribution system. For example, if you're overloading transformers or cycling, some of the voltage regulators, that might be a component as well.
Okay.
And you would be settling after the fact. You would also want to think about how to structure a forward market for that, in part because you want people to be able to hedge, in part also because I think at a distribution level, unlike the few thousand generators that the RTOs dispatch at the bulk power level, you're going to have literally hundreds of thousands or millions of smart devices that are in some way going to be interacting with the grid. And to some degree, you're going to have to convey some information to them that allows them to forecast. They may interact a little bit locally, but you're not going to have a distribution system operator that necessarily is going to know when I next need to use my vehicle, or what my temperature preferences are in my living room, and whether I'm in my living room or not, and therefore how the smart thermostat needs to react.
Yeah.
You're going to have to be using price signals to coordinate some of that information, as well as having some critical distribution level assets that you are going to dispatch at a DSO level.
Okay, so who are the market participants? Who's playing around in this market?
So customers can play around in the market. You also, so I think one of the things that, will emerge is to what extent you have customers that are assembling commodity and services for themselves, and to what extent you have something that looks a lot like a Crest supplier that is assembling and bundling commodities and services. And so they may also be playing, in this market.
Who runs the market?
So the market here is run by the operator of the transactional platform. Who is that operator is the question that Commissioner Friedman was asking, and it could be an independent entity that is operating the market. What we had recommended in our report for NYSERDA and the New York Commission was that independent entity might have utility sponsors, given the information flows that are necessary for that, and that you want someone has to, in effect, own the intellectual property that runs that market, and that might well be the utilities that do that.
Okay.
So what happens, I'm sorry to
No, go ahead, please.
interrupt, but, forgive me, Paul, you did a great job, number last. You all did a great job. Forgive me, Paul, but let's assume, for me, let's assume that it's not going to be, we're not going to restructure the distribution utilities and let them own the assets and then appoint a distribution system operator. Assume that they're the same entity, at least in phase one. Okay, so maybe in the future at some point it'll be different, but let's assume that they're the same entity at this point. How does it affect what all of you have had to say about market design?
So here, I think what you're saying is, if we look at this chart, we're talking about the distribution system operator as being the system planning and operations layer, the second layer out of the four going up. Then, I think that is, we can have this discussion about what's the best model for that, and whether that ought to be independent, as Paul suggested, or it can be utility. I think if it's utility, and I think this is kind of where New York came down, is you then want to think about what are the incentives, and can you create a different kind of incentive regulation so that the distribution system operator is not incented to, in effect, intervene in the market by saying, I'm going to overbuild transmission so that I don't look at, at other kinds of alternatives. And that requires thinking about what I would say is incentive or results-based regulation in a different way than what we've thought about before.
Okay, so let me just continue the line of thought. So, so I'm a chemist, so I know 1 + 1 = 2, and I could probably name you 20 elements off the periodic table. Then lawyer, and then from here turned, analyst as a commissioner to now implementer. And so that seems really hard. I'm not kidding, right? So I mean, what you're talking about seems really hard. I mean, the potential creation of a DSO who is the actual entity responsible for being the DSO, who's actually creating. We haven't even gotten to the service marketplace component of your slide. Who actually is doing that? That seems challenging, and that seems. I wonder if we actually have the authority to do that in actuality. So I'm sort of questioning that in my mind just from purely a legal perspective. And so let's say that we were to say in a policy document, and that's why I have an economist right here with me, because these. We could very well say that that this is the ideal situation, okay? But for now, here is this light that is something else we could do to potentially create a similar effect. What would that light look like based upon like the current restructured regime in the state of Ohio?
I mean, Mr. Chairman, I think that if you want to go down to a transition stage, and I think Commissioner Conway, I understand where you're going with some of that in your question to Paul on this, but I think that even with the distribution company still serving in its traditional role as the asset owner, operator, planner of the system, at the very least trying to get prices, locational marginal prices down to the distribution level, trying to get the pricing changed on how the wires charges are allocated based on location and time, whether people are using this at peak or not, I think can be done no matter what. The question then becomes how can you ensure, to Paul's point, I think I'm in violent agreement that it's now the incentive piece and the regulatory piece to make sure that the incentives are right for the distribution companies to not overinvest in wires, to make sure that they go look at non-wires alternatives per se, if they are available, to allow third parties, for example, here in Ohio with retail choice, it makes it a lot easier. You can have competitive load serving entities or other energy service companies that can offer and tailor to customers different products. So Paul mentioned, for example, the day-ahead and real-time market settlement process in PJM, and in fact in every RTO market in the United States. Perhaps there's a third party that can go out there and say, I will offer you a long-term deal for energy in a block. So it looks like a block and index contract. And if you choose to consume less than that block, we will settle it up at either the day ahead or the real-time price. You choose which one you want to do. This is already being implemented in the Southern Company territories with Georgia Power, Gulf Power, Alabama Power for their large commercial and industrial customers. And there's not even a true wholesale market there. And so if they can do that, I don't see any reason why something similar to that could not be done here in Ohio in that stage.
Okay. Just to follow up with Paul, it may be therapeutic to discuss what the current status is and where the real break point is going to be in Ohio. We have very little distributive generation that goes on now. And basically the system that we have is a funnel that came from the central power plant and goes down to the customer. And so when we're talking about those generators putting back, it's basically going through a net meter, into the system. It's sort of it's almost like delivery by displacement on the gas side. We offset the line loss in the system. That's where the distributive power goes that isn't being used by the host, as a practical matter. When we get above that number, there's going to be we'll have to redo the system, but that's the way it operates. Now, with that as background, what you were suggesting about, well, maybe what you need is an aggregator, and maybe it'll be the competitive retail supplier who's in the best position to put this together because they're operating as a load serving entity at the RTO. That probably is the answer, because they would have the data, and they could do that on an individual contract basis. But we have to get past that step where because we don't look like the RTO, and that we don't really have a system that's designed to move power from the distributive generator into the grid. It doesn't work that way. Does that make sense to you?
Yeah, I think I understand where you're going with that. I think that the issue is there's the technical issue as to whether the distribution system can handle bidirectional flows. Okay. Some distribution systems and assets don't do that very well. That's a technical issue that I think we would have to overcome. So if that's the case, then, your point about having to redo the system is something that we need to we would need to contemplate. But I think that even in New York, if one looks at REV and what's actually being deployed in New York State today, it's not going to be a net injector into the bulk power system at the end of the day at any of these nodes. It is going to be displacement. I think your intuitive notion of displacement like you have in the gas system is a good one, because it is in fact displacing those flows coming in from the bulk power system down to the distribution level.
Yeah, and I guess what I'm saying is that we've got an initial phase that's going to be easy, because up until the time that we fill the net losses on the distribution system, if we're putting in less than the net losses on the system, we have a free ride up to that level. After that, we really have to start thinking about how we can pair up the generation and the use.
So let me try to think about where help you think about where the near term and medium term opportunities are here. So I don't know that you're going to have bundles of PV or wind or something like that going behind the meter. I mean, you'll have some, because you have an RPS and you have some customers who want this. But the things that I think about that are near term and medium term is, one, I mean, get the voltage control right. You can save money, it's cheap, and it eliminates many of the constraints that otherwise would occur in the distribution system and gives you more headroom and more time. So that's number one. Number two, look at what you can do. And we'll talk about this in 2 weeks when I come back and talk about rate design. But look at what you can do as you're seeing more and more smart devices that can shift demand, because that can be very significant. You do want to pay attention to what's going on at the RTO level, because that will allow you to capture some benefits from doing that you may not be able to do today. It will allow you to create incentives for that to happen that don't exist in our retail market today because of the way we settle, and you need to pay attention to that. But those things are rolling out. They will, the forecast is that we'll have 5 times the amount of smart distributed connected devices in our grids 5 years from now than we have now. So that's another thing to pay attention to soon. I think we will get to a point, in sometime in the next decade, maybe early in the next decade, where we will see a tipping point on EVs. And we need to be prepared for that. And that's another kind of smart load that can be managed and can be integrated into the way we operate the grid. And we ought to pay attention to that. Finally, I would say, think about, what do you really want to do with net metering? I mean, just the fact that the net metering customer, even if they didn't deliver anything back to the grid, is avoiding paying for what are essentially fixed costs of the distribution grid. That's in effect a subsidy for having these rooftop PV, for example, that may or may not be cost effective, certainly are probably less cost effective than if you put a solar garden somewhere on the medium voltage system or somewhere near a substation where it could displace some need, and you could build it at perhaps a half to a third the cost of putting on rooftop PV on all of these PV sites. So those are kinds of near and medium term things that you can do at this point, and will help you get ready for for ultimately where you need to go in terms of building a market. But I would start with that kind of thing to begin with.
Just to sum up, it's sort of take the data. We're rolling out now our smart meters, and hopefully we're going to have some data flow that we've never had before. That sort of sounds like it's the enhanced demand response road. That's what I think is an easier road for us to take, because we've been sort of down that road before, and and we sort of have players who are used to that.
I'm gonna say it's, what you want to do is you want to get devices and demand that is responding to price. And here I'm gonna part company a little bit from what has happened as demand response at the federal level, where we both allow people to avoid paying their distribution rates, and we pay them a wholesale price on top of that for, reducing load from a baseline. In the future, that model will not work. If you get smart autonomous devices, in the best case, they will already have reduced their demand in what would be high price periods because they will respond to relatively small price differentials. In the worst case, they will anticipate that you're going to call a demand response event, increase their usage in what they anticipate to be the baseline usage period, and not give you anything real. So you need to move from this environment where we've created a lot of artificial incentives to actually doing something that prices, that reflects marginal cost and marginal value, and have that be the way in which you begin to integrate from the bulk power markets down into what become markets at the distribution level.
Yeah, and if I could add on top of that, to really reinforcing what Paul's talking about here, is that in a recent study that I did for the New York ISO and how they were going to implement some of the changes that are related to REV and how they were going to deal with this at the wholesale power level, so sort of reacting to the retail initiatives as opposed to the other way around. I think one of the issues was one of baselining demand response, or energy efficiency, and as you get these smart devices that are going to be moving to price, it's going to be almost impossible to baseline anything with any reasonable accuracy. I mean, today's baseline methodologies are not exactly great either, but it will become absolutely untenable, and that was why I was suggesting, contracts along the lines of, where you buy a block, and that block is really your baseline. It's a contractual baseline. You bought it, you own it. Now you can sell it back, or you can consume more over top of that. And what that also does, from a practical perspective, that Paul didn't mention, is that it eliminates this whole cottage industry and complication of measurement and verification that comes along with it. With all of these baselining methodologies, your only M&V is read the meter. It's very simple at that point.
Other questions? Beth?
Hey, Paul. Is there any state that has implemented a distribution system operator?
None that I'm aware of.
Is any country outside the U.S.?
Not in the true sense that we talk about. As a distribution system operator, where it's completely independent. There are incentives set up such that for some European distribution companies, they have incentives such that they would look like they could look like a distribution system operator, given the incentives, even though they are the asset owner still.
So can I ask you a question? Do you think a distribution system operator is something it's the wave of the future? Is this just a conversation we're having about what would be nice? I mean, I'm trying to understand how we talk about this in the right way. And is this an aspiration, or is this something you think that has to happen if we're going to move forward?
I think there's a combination of things that sort of leads us to the whole DSO concept, as at least I've described it. I think the one is the incentive regulation that we see in Europe and Latin America at the distribution system level that doesn't exist here in the North American context, whether it's the U.S. or Canada. But I also think that there are these other trends, and so one is contracting out the operation of distribution systems to vendors to operate them under various incentives. So they're not necessarily the asset owner, but they're contracted out to operate the system. And if they meet certain metrics or goals, they can get bonuses, or if they do poorly, they'll actually be penalized for doing that. I think there's an example here in the U.S. That's kind of similar to that, and that is PSE&G operates LIPA's distribution system. Even though they don't own the LIPA assets, those being a public power authority, but they were contracted out to run the distribution system. They're not the asset owner. And so that's not exactly a DSO, but I think you're seeing trends that start getting you there. Will we get there tomorrow? No. But I can tell you probably back in 1992, the thought of having an independent system operator before Order 888 and 889 in 1996, I don't think many people would have thought that that was very far or very near term either. So it might be just a matter of will, but it's also a practical matter. I think, Commissioner Conway's comment that's about this is that, can we actually make that happen in the short term? Maybe we can, and we have to look at all the other alternatives.
If I can.
Anyone else? Yeah, I have a
if I
question.
can just jump in a little bit. So, picking up on our last conversation about incentives, if you look in other parts of the world, there are places where regulators have tried to deal with this incentive to invest in capital and create efficiency incentives. So Rio in the UK is one example. So in the UK, what the regulator does is it sets an overall revenue allowance based upon a forward projection of business needs. Once that is set, the utility is free to spend that, either on capital or on operating expenses. The revenue allowance is divided up front between fast money and slow money, which is the equivalent of capitalized funds, but it is unrelated to what the utility actually spends on. Now, in New York REV, the New York Commission tried to take a look at this TODEX mechanism. They decided not to go there because of concerns with generally accepted accounting practices. I think that one way of addressing that, the concern was that their utilities had lots of deferred assets, and it wasn't clear how the deferred assets under GAAP would play in a TODEX framework. I could imagine our commission doing something slightly different than what was before the New York Commission and say, we will take a TODEX perspective for new investment and expenditures and continue to deal with our deferred assets the way we've traditionally dealt with them under GAAP. And that might be an acceptable approach, although you would certainly want to talk with your accounting experts to see what their opinion of that is. In Australia, they deal with this a slightly different way. They have separate operating and capital expenditures, but they've tried to create incentive mechanisms around operational and capital expenses that they regard as roughly equivalent, as another way of approaching the problem.
Sandy Brett, I want to hear from you. Well, yeah, I think I think you're probably catching the tenor of our questioning to say that this, while we may from a policy perspective say that in theory this is a wonderful idea, from an economics perspective, this would be the clearest way to do it. Talk to us a little bit about what you, from your perspectives, what you think a potential Sandy, you don't agree that this is a solution actually, right?
Not really. I think I don't think we can say that yet. To your point, can we say this is where we're going to head? I'm an advocate to begin with the end in mind, so we can see this on the horizon. But you said, gosh, this sounds really hard. Well, that's because we're trying to solve for X way out here, right? And I think there are steps we need to take. And if I'm sitting down with a utility, right, and we start having these kind of conversations, what we really do is talk about that roadmap and the strategy we want to put together of, okay, I want to be prepared. I want to be prepared for this, right? Whatever this might be, and I think it might look like a DSO in the future. What are those things I have to do today that already support my utility and where I need to be today? To your point about VVO, right? Managing voltage is a big deal, right? And it becomes a bigger deal as these things, even though we don't have a lot of it today, it becomes a bigger deal as I start putting this stuff on the grid. I have a lot of devices in people's homes and they're able to manage their demand more than they ever could before. So what kinds of things can I take advantage of and do today that take advantage of what exists or what's on the very near-term horizon, like those things that Paul mentioned, that also set me up so that if I am the platform in the future, if that becomes the platform in the future, I've started to establish that foundation. So I don't think you have to have all the answers for this, but I do think you have to kind of keep that in mind and put the programs in place that kind of solve today's problems, take advantage of today's technology, don't preclude us from doing things that might enable us to do that in the future. And that's really what we encourage our utilities to do.
Bradley?
Yeah, I think there's real value in customer distributed energy technologies, and the fact that there's not a lot of them now is a really good place to be, because you can actually plan for it and embrace the value as the adoption rate grows. And so things like smart inverters as a standard for electric vehicle charging and rooftop solar. That just makes perfect sense, because they're the ones causing the voltage disruption to begin with. So smart inverters that would mitigate their own disruption would make perfect sense. And the ability to have controllable smart inverters actually creates more societal benefit, because now you can leverage the reactive power capability of smart inverters. How do you incent that without markets? There's ways to do that, is some non-wires incentives, for example, to say, yes, it's much lower cost to put little controllers in distributed processes on air conditioners or on smart chargers that can take into account these benefits. So it's a matter of how do we create this incentive platform, if you will, that utilities can offer to their customers.
Okay. I know both of you have quick questions, right?
Go ahead.
Mine's quicker than yours. Am I to assume that if we do come to a DSO paradigm, that they assume the polar responsibilities?
There's a lot of ways of solving the polar problem. I mean, in Illinois, you have a separate Illinois Power Authority that does polar procurements. You could do what some places have done in gas markets and or Texas has done, and just assign out the polar responsibility. So I come back to what I said in my prepared remarks, that I think it matters what the default is. And if the default remains a flat commodity price, you're much less likely to get innovation. If you go to something, and we'll talk about this more in a couple of weeks, that looks like some combination of the pricing that Paul was talking about, where you have a combination of a dynamic price and a hedge as the default, then you can maybe begin to see how you could have additional services. And and it's not difficult to get to that point. Even if you start with looking at what's the LMP at the load node in the RTO that is proximal to where customers are. Can you add to that, for example, a factor for marginal losses that can be readily computed? You can very quickly get to a point where you're starting to get a dynamic component that makes sense. Doesn't take the full DLMP market, but you're beginning to get some price signals to customers that make the system more efficient, and also do that in combination with a hedge like a block and index, or what I might call a kind of insurance policy plus a dynamic price, and that can be done by almost any entity that you want to assign it to. It could be the existing utility if you stick with this model where the utility it functions in the DSO role, which by the way, they are going to have to do to some degree regardless. I mean, if you change nothing, they will fulfill a DSO function. Now, they may fulfill it by saying, we're just going to build a more robust distribution system to manage all this stuff and not get you any of the efficiencies that I think this is aimed at. But if you do nothing, they will play some form of that DSO role.
Yeah. Mm-hmm. Dan.
Just for Brad, IT, OT, CT, information technology, operations technology, and then customer technology. One of the things that I see, or I gather from all the conversations we've had, is that customer devices at the edge are proliferating, and it's an avalanche coming at us, and it's an opportunity and a challenge, right?
Absolutely.
So the customer technology, if we get the IT, the OT, and the customer technology right, then as I understand the way you're looking at it, we get not really even a virtual, but an actual complement to the infrastructure that the utilities have traditionally provided that achieves the reliability and adequacy objectives.
That's right.
All right.
And the CT includes distributed processes, meaning they can sense and respond. They don't have to wait for a signal. They know their voltage, they know their frequency, they know.
The question, that was my first question, did I understand what you were trying to describe for us? And but the follow-up question is, I wish you could give me some comfort, some additional confidence that we can in the future actually rely upon or count upon all these 1,000 points of light or whatever that are emerging at the periphery. They're actually going to substitute for what we have traditionally come to rely upon as the reliability provider. That they're going to be we're going to be able to count on them in the same manner. As I got to tell you, I have some concern about it. I know we're facing it. It's coming. And it's an opportunity as well as a challenge, but can we really count on?
Well, yeah, and because they're so small to begin with, in any given one, probably not, but probability says in aggregate there's a certain amount you can count on, and statistically you can determine that there is some amount that you can count on, and means you may have to actually offer this to more than you need in order to get what you expect.
Do you think that there's also then going to be, I know statistically it's going to work out, it still makes me feel a little bit uncomfortable, even though the quantitative areas are something that I'm comfortable with generally, but still I have some level of discomfort about it. Do you think there's going to be, about this circumstance, do you think that it would make sense to have to build in some kind of, on the to be safe, to have some sort of reserve margin or some sort of something more than we currently have to accommodate the fact that we just don't control or we don't regulate, maybe it's because we like to regulate so much, and we're not going to be able to regulate this quite to the same extent. Would it make sense to have some reserve margin, some buffer that the utility or whoever the system operator would provide?
Well, yeah, and I think that actually can be regulated by some of the reliability and availability standards that you set, and that if they can't get that based on the performance of the DER, then they have to have, like you say, some buffer in order to assure that they are meeting the reliability standard.
Yeah, I think that actually to back up what Brad's saying here is that for demand response for third-party aggregators and wholesale markets, they do exactly that. They contract with more than they actually need for exactly that reason. So I mean that's we're already seeing that happen.
Sandy?
Yeah, so we have a few examples already to maybe help you a little bit with your comfort, right? I mean, you've got we have some behavioral companies out there that have demonstrated that they have some consistency with how the customers behave, and I'm thinking O-Power, right? And then I'll put on an old hat of mine. I worked for Converge for a while, they're a DR provider, and we actually had hundreds, at least tens of megawatts, and in a couple places 100 megawatt systems that were demand response that were actually by some commissions considered as, reserves because they were so reliable. So can we get there? Yes. I think we can. You have to oversize it, right? And you have to have some reserve. But we have some examples, right, of us being able to do that as an industry. So.
Okay, I'm feeling better already.
You can
Thank
sleep
you.
tonight, Commissioner Conway.
Tom.
Mr. Chairman, I just wanted to make more of a comment than that. I just think that perhaps we should have a Plan B, just in case.
You stressed us out. We're all super stressed now. We thought we were good until this panel.
Yeah. No, I really think that this panel has given us a lot to think about.
Okay,
And,
Benedict. Sorry. Oh, sorry. I'm sorry. I didn't mean to cut you
No,
off.
I just mean that I think you've given a lot to think about. I do think that call me practical, but I am, Sandy, interested in those first steps. Not now, but you understand what I'm saying. All of you do. Thanks.
Tim, Christina, last words. You sure? You don't want to memorialize forever on YouTube? Okay, thank you very. This was an excellent discussion. Thank you very much. Thank you for coming all the way out here to Columbus to do this. We're really appreciative. So well done. Okay, this wraps up week 1 of phase 3. An excellent 3 days. I want to give a shout out to our commissioner aides who have been really hustling this week. I've been seeing them run around everywhere, trying to accomplish tasks great and small. To our public affairs team, who's really been on it this week as well. So thanks to those guys. OGTV, I don't know how you're still awake. I mean, this is like some serious technical stuff. My sister tuned in for 15 minutes and was like, "I'm done. Thanks." So thank you guys for your diligence. When I mentioned Paul Santallella's presentation, they like pulled it up in a millisecond and had the slide out. So really well done. And to the folks on the bench who are like some of the last remaining souls in this room, thank you very much for your level of engagement. I think it's extraordinarily important as we move forward that we're all in it and we're all thinking about it. So thank you very much for that. Okay, with that, we will see you on March the 20th. We are adjourned.